Hey there, kids. Thanks for coming in today. Today we're going to look at classifying triangles, both by angles and their sides. You can see we have two goals to get through today. To be able to classify triangles by their sides and angles, and also to use those classifications to find missing angle measures or missing side lengths. All right, so this is going to begin our first section or our first chapter of looking at triangles. So we can see here this picture on the right. Over here, this is called a triangle, obviously. All right, to name that triangle, we would name it by its three vertices. You say triangle, and then the vertices can go in any order. So we can say GEO, or EGO, or OGE. Any order is fine. The three angles then would be angle G, angle E, and angle O. And the three sides would be segment GE, segment EO, and segment GO in any order. Triangles do come in many shapes and sizes. We can classify them in two different ways, by their angle measures or by their side lengths. And that's what we'll look at here on this next slide. To classify triangles by their angles, there are four different classifications. The first one, if all three angles are acute. So maybe that would look like this. This is a 40, 80, and 60. Three angles. That's called simply an acute triangle. However, if two of those are acute, but we switch one of them over to be right, so now let's say this is 90, this is 40, and this is 50. Now this is called a right triangle. And if we continue to switch that one angle, now we switch it over to an obtuse angle. So maybe this one now is 120, and this is 40, and this is 20. This triangle is called an obtuse triangle. And lastly, if we have all three are 60. Now this is called an acute triangle, but it's a special kind of an acute triangle that we call equiangular. So those are your four different classifications by angles. By sides, there are only three different classifications. So let's say first we have all three sides are different lengths. So maybe this is 5, 7, and 8. This is called a scalene triangle. All right, now let's say two of them are the same. So 7, 7, and 9. This is called an isosceles triangle. And lastly, if these are all the same, so maybe 5, 5, and 5, this is called an equilateral triangle. And a quick important note here, these two go back and forth. They're interchangeable. All right. If it's equiangular, it's automatically equilateral. If it's equilateral, it's automatically equiangular. Okay, so these two have a connection that if it's one, it always has to be the other one as well. All right, so we're going to take a look at a couple problems here. It says name the three triangles in the picture and classify them by their angles. So we see one triangle over here. That's triangle ABC. And let's take a look at their angles. Well, we got 30 and 30, and then we're missing one here. So remember, this is a linear pair. So we have to add up to 180. So we do 180 minus 60 to get this angle is 120. So therefore, that triangle is an obtuse triangle. Okay, then we have another triangle over here. Here we have triangle ACD. Two of the angles are 60, but we don't know the top one yet. Remember, this means 90. So we do 90 minus 30, and we get 60. And therefore, this is 60, 60, and 60. That's called equiangular. And finally, we have the big triangle here. So the big triangle is called triangle ABD, and those angles are 30, 60, and 90, and that would be called a right triangle. All right, down here, we're going to classify these three triangles by their sides. So again, let's take a look at, let's start with this triangle here. Remember, the tick marks mean that those two are congruent. So if this is 10, then this is also 10, and so is this over here. I'm going to put all those 10s down there. But mainly looking at that blue triangle right now, we'll call that triangle BAD. And since all three sides are 10, this is called an equilateral triangle. Okay, and then looking at this triangle over here to the right, we'll call that triangle BDC. And you can see the sides are 19, 10, and 10. So two of the sides are the same. That's called an isosceles triangle. And then finally, looking at the whole thing, sorry, just fixing my triangle here. Looking at the whole triangle, the whole thing here, we can call that triangle BAC. And the side lengths are 10, 19, and 20, because this whole side here is 10 plus 10, 20. So 10, 19, and 20, they're all different. This would be a scalene triangle. All right, so now we have a right triangle below here. We're going to just talk about the parts of it. Okay, the two sides that meet at the right angle, those are called the legs. The legs could be equal or they could be different. In this case, it looks like they're different. The third side, which is across from the right angle there, is called the hypotenuse. Okay, it's important to understand the hypotenuse is always the biggest side in a right triangle. Down here we have an isosceles triangle, again labeling all the parts. So it looks like these are congruent sides. Those are also called the legs. In an isosceles triangle, the legs are always equal. The third side is called the base. Okay, across from the base, this angle up here is called the vertex angle. And the two angles that are on the base are called the base angles. And we'll learn in our next lesson here that the base angles are also congruent. But a little preview of what's coming next. All right, given information about triangle ABC, classify the triangle by angles and by sides. So for the first one, we have 5, 6, and 7 on the sides. That's scalene. And as long as we have one obtuse angle, this is called an obtuse triangle. So scalene and obtuse, or obtuse scalene. The second one, we have two congruent sides here. So this is isosceles. And the angle between them is acute. And if we were to draw that out here, these are both the same, and that's 72. There's no way that both of these could be obtuse or right. So this one has to be acute. The third one, clearly a right triangle right here. And since the two legs are different sides, we know the hypotenuse has to be a different length as well. So this is going to be a right and a scalene triangle, or a scalene right triangle, it doesn't matter the order. All right, and lastly, we have two sides that are congruent, but the angle between them is 60. So if we were to draw this out, these two, since they're congruent there, would also be 60. So this one is called equilateral and equiangular. And like we talked about before, if it's one, it has to be the other. All right, so now we have 3 points in space, and we're going to classify this by its side lengths. All right, you don't need to draw this out, but I'm just kind of showing you what we're doing here. Here's A somewhere up here. Oh boy. Let's try that again. Here's A somewhere up here. Here's B. And C would be over here somewhere. Okay, so we have a triangle. And we got to find the length of those sides. Let's start by finding the length of AB using our distance formula here. So that would be x minus x squared plus y minus y squared. And that would be 1 squared plus 7 squared, which is root 50. Okay, we can reduce that to 5 root 2 if we want, or about 7, but we can just leave it like that for now. For the purpose of this problem, that's all we need to do. And then BC, x minus x squared plus y minus y squared. And again, we get 7 squared plus negative 1 squared, which is again root 50. Finally, AC, x minus x squared plus y minus y squared. That's 8 squared plus 6 squared, which is root 100, which would be 10, but again, we don't really need that. But we have our 3 side lengths here. 2 of them are the same, so therefore this is called an isosceles triangle. Number 7, triangle JMN is isosceles with base JN. So if we were to draw this picture here, JN is the base, and that tells you, very importantly, what 2 sides are equal. Okay, if JN is the base, that means this is your vertex angle, which means these 2 are equal. Okay, so now, why does it help us? Well, JM is 2x minus 5, MN is 3x minus 9, and JN is x minus 2. Because we know these 2 are equal, we can ignore this and just set these 2 equal to each other. If you solve that, you get x is equal to 4. So finally it says to find the measure of all 3 sides, put 4 back in. JM would be 2, MN would be 3, and JM would be 3. All right, last one here. PQR is isosceles with vertex R. So we're told that R is a vertex, which is very important because that tells us that these 2 are equal. And then we're also told PQ is 2x plus 7, PR is 3x minus 3, and QR is 12. And again, we know these 2 are equal to each other. So 3x minus 3 equals 12. X is 5. And then it says to find the measure of PQ. So 2 times 5 plus 7, PQ would be 17. All right, that's it for today. Go back and ask yourself if you've hit your 2 goals today. Could you classify triangles by their sides and angles? And can you use those to find angle measures and side lengths as well? Mostly just side lengths today. We'll talk about angle measures soon coming up. All right. Thanks for checking in today, and we'll hope to see you soon.